Phrase it.
By the way,
So we just
sir,
ask them?
31 minutes.
Look at the book. It gives you specific questions to ask.
Okay.
You're asking how do you phrase how do you phrase a sentence that you don't know? Like, how do I rephrase the unknown? You can't ask that question. It's a wasted question. So you get the questions down, and then you decide how do you rephrase it in the context of your particular project. All right, so homework for today was to add the logical Boolean operators to our language. Now, you could have done this a couple different ways. Do we already have a Boolean expression?
Locally, but not.
Right, so we have, in our question thing, we ask whether something is equal to 0. So we have this like presumed Boolean thing, but we don't actually have something of type Boolean expression, correct? All right, so, because really, when we think about our core languages, when we talk about programming, when we talk about beginning programming, we think about things in terms of Boolean expressions, right? So if I go back here, where's my latest update? Okay, that's math op language. All right, so if we come here, we might say we have a bool expression. And so if I was asking this in like a 200 or a 250 class, and I said, what's a Boolean expression, what would you say?
A true or false statement.
Any expression that boils down to a single value of true or false. Remember that one? Okay, and we had the little mantra, any expression that boils down to a single value of true or false. Okay, so a Boolean expression ultimately gives us a true or it gives us a false. Now, what I'm going to do is I'm going to slightly modify it in our language to represent something that is how Objective-C works for Booleans, and I've always kind of liked. So we might as well bring it into the language here, and that is instead of true and false in Objective-C, we have yes and no. Yes means true, no means false. Okay, so we're going to have our Boolean expressions are going to boil down to either a yes or boil down to a no. All right, as a symbol, quote yes, quote no, something like that. All right, that'll separate us a little bit from using just normal standard logic. Make sense? All right, so we're going to see a Boolean expression is a yes. Well, it's going to be a lambda calculus expression that ultimately boils down to a yes or a no. Okay, so go ahead.
Can we instead change these to ya and nine?
Ya and 9? Is ya like this? Is that 9?
Yeah.
Or is it N-I-E-N?
N-E-I-N.
Yeah, it's spelled with a J.
Okay. Ya is a J, like this? Is that right?
Yeah.
So that was accurate?
Yeah. This is right.
Okay. Sure. So let me. We're gonna create a language of boolops. The boolop language is either ya or 9. It kind of reminds me of this YouTube video where this guy was teaching somebody how to like enunciate German, and he just kept saying 9 over and over. It's like 9, and the other guy would repeat it. It says 9. The other guy would say, I mean, it sounded like he was saying the identical thing, but he just wasn't right for whatever reason. Okay, ya, is it ya? Is that how you say it? Or 9? Am I pronouncing that right?
Or?
No, or.
Yeah, it says or.
Or. This is or.
Oh.
Those are my options.
Okay.
Ya,
I thought you said
ya or 9.
Yeah, hold on 9. Okay.
What was that thing?
That's not the language.
Oda?
Oder.
Odor.
O-D-E-R means or.
Order.
Ja,
Oda.
oder
Oder. Ya oder 9. Man, I almost sounded German there for a second. That's very bad for my particular heritage. So this is a rough. Here, well, for the Ann Arbor students, I was most of my family is Orthodox Jew, and they were Polish Jews and spent some time vacationing in Auschwitz. So that was a rough patch for the Libyans back then.
When I went to Israel,
Yeah.
I can understand some Hebrew, so I'm like hearing these people speak Hebrew, and I can understand some German. You hear people talk German. There's people speaking Yiddish, and I'm like, what am I listening to?
Yeah, I have one living grandparent, so she doesn't everybody speak to it anymore. But my grandma and grandpa, when he was still around, would speak Yiddish.
Yeah.
Yeah, we got some. Yeah, only my brother and I are Christian. Everybody else is. I mean, I have like uncles that are super Orthodox, like practice their profession in like the garb. And have all the curly things. And they got stuff. But when I went to Israel, I to the left of the Wailing Wall, they have the Holy of Holies. They only let Jews in. They waved me right on in. I showed them the nose. I'm in. So it's like the green card.
Hey, well, I went in there.
Really?
Yeah.
You're not supposed to.
Well, nobody told me not to.
Yeah, it's like a big rule. You got those scribes and stuff?
Yeah. It was really cool.
Yeah, I know. Yeah. You weren't part of the team.
I was nobody stopped me.
You weren't. Because I was there with a church group, and there was like 25 of us, and I was the only one that got to go in. Nobody else like tried to go in, so it's possible they just kind of think like not ignorant, right?
Yeah.
I'm wandering in. You're just going. And the funny other story to that is when I was at the Wailing Wall, I had my arm up on the wall, and a bird pooped in my arm.
Isn't that supposed to be good luck?
That's what our tour guide told me, like legitimately. Okay, but you're standing here at the Wailing Wall. This is a very holy place, right? Okay, and you have, this bird was having some digestive issues that day, so this was not like a barely hit. I was hit by the dump truck of birds. So I had this on my arm. So I mean, you can't just sit there and smear it on the Wailing Wall. You're gonna get in trouble, right? Okay, so I'm like standing there, like, what do you do with it? I mean, I don't have, because you're supposed to leave all your stuff behind. So I'm up there with like a backpack and stuff. It's like this, and once you're there, you're supposed to go over to the Holy of Holies if you're allowed. And at the Holy of Holies, you could pick up a yarmulke on your way in. So like, do I wipe this down with a yarmulke? And I'm thinking, I don't think so, because some of those folks there get intense, like legit intense. So I just rolled with it and then let my wife clean me up when we got back to the group.
Well, hey, at least you weren't eating a bagel when it happened.
Well, mixed it with the cream cheese.
No, so
How does this transition? At least you weren't eating a bagel when the bird pooped on your arm at the Wailing Wall.
When I was young, my family went to visit the seminary in St. Louis, and you can always get a bagel from the food bank.
Okay.
And so got a bagel. We're walking around. All of a sudden, I just hear this plop on my head, and just dawning on me what just happened.
Mm-hmm.
I'm just like, I don't trust anything on my person.
Okay.
At that point, not even the bagel.
Oh, so the bagel really has nothing to do with the story, other than the fact that you happened to be carrying a bagel at the time.
Yes.
Must have been a
Yeah,
traumatic
that was.
It was.
All right.
I'll never forget this.
All right, so we have our language of Boolean ops. Language of Bool ops, we have ja and nein. All right, so what we're going to have is for our, is it further down or is it up? So for a Boolean expression, we're going to have a bool. Let's call it bool expression like that. And this guy will be a lambda calculus expression that we presume boils down to a actually, this will be a, it's something that will ultimately boil down to a bool op. I think that's fair. All right, which in our world will likely be a Could be a lit expression or something like that. So now we have a new kind of thing we know how to store, a new kind of literal. Before we just had literals of numbers, right? 0 through 9. Now we have ya and nines. Not to be confused with 9. The number 9 versus the Boolean 9. So don't get confused. Well, at least we. What's the Vietnamese yes and no?
Just keep going.
Well, I'm interested. How do you say yes and no in Vietnamese? Is it not sayable? Is that pronounceable?
There's no vowels.
I mean, I'll show you later.
Google Translate. There you go.
Because I'm fluent in Vietnamese as long as you show me the word and tell me how to pronounce it.
Sung, U, accent, U, and
Accent?
yeah. It's like D with the dash, and then U with the thing, and then NG.
Is it Google Translate? Can you just dictate it?
Yeah.
So is it Dung? Dung?
Dung.
I don't think that's quite right.
Dung.
Dung?
That's yes.
Dung? That's yes?
And Kong.
And Kong?
I can't. That's not the right
Be
one.
help-
Well, I can't read that. What is it?
Not my fault.
Hong? Hong?
K H.
Hong? Hong?
This is fun.
Hong?
O
Me. Help us.
G.
Jesus Christ.
All right, so we're going to go with ya and 9. So that's our bool ops. So our lambda calculus expression for this guy is going to boil down to either one of those. So now if we go back into our language. Let's, did we give ourselves a... We didn't give ourselves constructors for math ops, right? We just decided we have the two, like plus sign, minus sign. These are just, you only go so far, right? Okay, so we won't give ourselves constructors for bool ops. We'll just know that it's ya or 9. Ya. Do you do the little accent thing, or is that disrespectful?
What?
Like if you say, like, do you say it with like a German accent, or is that?
Well, I mean, if you're speaking German,
Yeah.
as authentic as possible. I mean, you can speak it with an American accent. It sounds awful.
Oh.
Nine.
9.
But it's actually ja oder nine.
Ja oder 9.
Very, very, very fluid.
Okay, yeah, so I said it perfect, I'm pretty sure. All right, so we need to adapt our lit expressions. So our lit expression is just boils down to an expression. Now, do we actually force lit expressions to be numbers, or that just happens to be what we've used up to this point? Yeah, so right now a lit expression constructor is taking in a number, but really now it's a value, correct? So, we might change this so we have maybe it's a lit value, and it'll boil down to that lit value. Now I realize it's just a variable name we changed. We didn't actually change any of the logic there, but when we go back and look at this later, we might be interested in knowing, this tells a story about what we're dealing with here. Similarly, a var expression, which is going to be something we're going to want to, we now want to be able to store Booleans, store Boolean ops, and then boil down to a var expression should be able to boil down to a Boolean literal. All right, so our lit expression isn't going to change. We are going to define, we'll just do it right here after lit expression. We're going to define a bool expression to be a lambda that's going to take in a bool val, or is it maybe bool op? Called a bool op. And this guy will boil down to the bool op. Well, actually, we decided to be a list, right? So a list containing bool exp and bool up like that. So it'll be like bool expression ya or bool expression 9. I'm going to be totally fluent by the time we're done with this. All right, so now we want to have the ability to ask, is something a bool expression? So this would be a lambda that's going to take in an expression. We call the other ones EXP or EXPR. Oh, lambda calculus expression. All right, and what we're interested here is whether or not the car of LC expression is equal to bool exp. That tells us whether or not we're dealing with a Boolean expression. Okay. And then we're going to have a define bool expression get val, something like that. This guy will be a lambda that's going to take in a bool expression, and ultimately it's going to return the catter of the bool expression. So that should give us our actual Boolean value of ya or 9. Okay. So let's say that's good enough for right now. We'll fly back up here. We'll go ahead and implement that for our Boolean expression. We'll put this right after our lit expression. So bool expression EXPR is ultimately going to boil down to, so notice that when we built our lit expressions, we just had that stored as a number, didn't we? I want to check our check for our lit expressions. Yeah, it just asks if it's a number. So if it's not a number, we actually could do our bool expressions without. Because if you see how we build a lit expression, we just boil down to lit value. We could do the same thing with bool expressions, just have them boil down to the value rather than package it in a weird list thing. So why don't we do that? We're going to call this guy bool. Go ahead.
Is that going to interfere at all with how we are using our var expressions? Because right now we're treating the var expressions as just a symbol. I guess my question is, how are we going to check for whether it's a Boolean expression or not? Are we just
I see what you're saying.
Yeah, we're just going to check for the symbol, because then we're going to have an issue with the vars.
Yeah, you'd have to look to see if it's very specific symbols.
Yeah. Which isn't.
Yeah, I mean, because you can't name a variable true or false and see.
Sure.
So I think it's okay.
Okay.
So we'll call this guy a bool value, and instead of boiling down to the list, we'll just boil down to our bool value there. So that's our bool expression. So now we don't actually need to get a value from that because it is its own value. So we don't need an extractor. All right. And for checking to see if something is a bool expression, what we're really interested in is whether or not it's a symbol. And now we could actually, I don't even think we need to ask the symbol thing. We just need to return or EQ yeah. That or EQ 9.
Except for the dash for EQ.
Oh, thank you.
That's that way.
All right, so if what we're looking at is either one of those things, then it must be a Boolean expression. Okay. So now we can come down here. Here's our Boolean expression. If it's a Boolean expression, what are we going to do? We're going to boil down just to the value. So same thing as our lit expression, but we are identifying it as specifically a Boolean type, right? A lit expression is a numeric type. A bool expression is a Boolean type. Okay, so even though this guy, we do the same thing with the value, we can presume if we're looking at a Boolean expression, this guy will be either a ya or a nine. Okay, so that's it for that. Now for var expression, we have an expression we'll call apply NV on that expression. So a var expression is what? It's a name value pair. So we say remember A is 5. So will this work for like remember A is ya? Do I have to do anything special? No, it stores a name value pair, right? So remember expressions now work just as they worked before. We just now have a new value, a new type that we can pull out of there. Okay. So now for remember expressions, we can actually modify these guys now to I'm sorry, not remember expressions. For questions, where's my question? So a question expression, we can now change the way we handle Booleans, right? Instead of doing the whole zero trick that we did, been doing. Like, well, if it boils down to a 0, we're going to treat that, what do we treat? A 0 as a false and anything not 0 as a true. All right, well, now we could say ya or 9, right? So here's our Boolean expression. Boolean expression is going to be the catter of our expression. Now what we're doing is we're calling apply expression on that Boolean expression and checking to see if it's equal to 0. We no longer want to know if it's equal to 0. We now want to know if it is equal to 9, right? Because we're doing the false thing first, because that's the way we wrote it. All right, so if it's equal to 9, then we will boil down to our false expression let's see, so if it is null, just boil down to the expression itself. Otherwise, we'll call apply expression on what that expression was and in our current environment. Else, we'll call apply expression in, now we could say it's else says if it's anything but 9, do this. We might want to specify here that we want it to be ya or 9, and then maybe give us some sort of weird error if it's something else. So what we might do here is we might say, so here is, we might convert this guy to a cond and then say equal that, do that stuff. Actually, we'll need to do this. All right, so if 9 is equal to whatever that boils down to, then we will do the body of this, which is that stuff, right? EQ, yeah. Probably should have done this inside of a let. But, what are you going to do? Actually, we can do that, can't we? We can actually call our apply expression up here. call that bool val. So bool val will be our apply expression on the counter of our expression inside the environment. So now what we're actually doing is we're asking if our bool val is equal to 9. So if that guy is equal to 9, then do all these things. Otherwise, if bool val is equal to yeah, then we'll call apply expression, probably do something pretty similar here. I don't know, we must have had some very specific example where we thought that
Is that for if we don't, so we only have to have a true case with our questions? So we're checking if the false is happening.
oh, that's right. Yeah, is in case we didn't have a false. So we'll always have a true, so we don't need to ask that question again here. So apply expression, true expression, ENV. That's going to come to here. Okay, so actually it's going to come to there. So that's what we do if we're looking at yeah. Else, we have some sort of like not a Boolean expression or something like that.
You got an error, don't you?
Huh?
You got an error?
Do we?
No. I mean, for that else statement, we do it instead of a German.
Oh.
Mitch, what's a good German thing for error?
For error?
How do you say error in German?
Good question. I don't know the word for error.
Huh?
I've never come across.
Error.
Huh?
That doesn't surprise me.
It's error.
Error?
Yes, it's the same word.
No, it doesn't.
That's boring.
No,
You do
it's
proxy talking.
feller.
What is it?
F-E-H-L-E-R.
That'd be failure.
Failure? Oh, like failure.
Kinda, yeah.
All right. It's like, why is your code switched to German?
Because why not?
Okay, so so now we have our.
It helps to show that the computer doesn't run on English.
That's right. All right, so we'll boil down to failure if we something bad happens. Otherwise, we'll execute the correct things. All right, so let's go and test this real quick. Did I leave my code in a working state before? I do not remember, but we are definitely going to have something simpler than this. So let's create a bool expression. Yeah, I misspelled it. Okay, and then we're going to do a question. Was it question exp? Var exp b, and then we'll just have our true. So we'll have our lit exp 1, and we'll test the false too. Lit exp 2. All right, so there's our test expression. So we'll remember a b is equal to yeah, and then we'll ask if b, so if it's true, then boil down to 1, otherwise boil down to 2. So this should give us a 1 in this case. So there's our 1. And if I change this to 9, this should give us a 2. And if I change this to LOL, this should give us a failure. Failure? All right. How do you say it?
Failure.
Failure?
It'd be failure, yeah.
Failure. Failure.
Like failure, just with a little bit of pizzazz.
Pizzazz.
Well, like one who fails. Failure.
Failure.
You could say my failure would be
Failure.
mine a failure.
Oh, geez.
Mind a failure?
It's that like that commercial. Have you seen I think it's for one of the pieces of software for learning a foreign language, like where he has these two guys that they're trying to learn Spanish, and they're like in this cross-country road trip, and so this like Spanish music channel comes on, and they almost change it, right? You know, there's things like, oh, well, go ahead and change that. We don't understand that. And they decide to leave it on. And it's like, 22-hour road trip later, these guys get out of the car and they're just speaking to each other in fluent Spanish. You haven't seen that? Oh, yeah, it's a Rosetta Stone commercial. Something like learn Spanish the right way or something like that. Yeah, it probably depends on how you learn.
Rosetta Stone.
I tried it for like 3 months.
Yeah.
Wait, is that the car?
Oh yeah, no. Rosetta Stone is just fancy flashcards.
Yeah, it teaches you how to ask questions to learn like a beginning Spanish class. I feel like the 3 months.
Yeah.
How many of you have ever seen, I don't know why this popped in my head, how many of you have ever seen the show Airwolf?
Never heard of it.
It sounds familiar.
Okay, well, you know Knight Rider, right?
Yeah.
With David Hasselhoff, he's got the talking car. Okay, and then back then there was also a show called Street Hawk. Okay, that was a guy with a motorcycle. Airwolf was a guy with a helicopter. And all the bad guys in the show also had helicopters. And what was great about this show, I mean, this show is awesome. It's like a top 5 best show ever. Don't judge the acting, but like, because it was like the Airwolf was the name of the helicopter, and it could do like Mach whatever, Mach 5. It was just crazy stuff, right? And the theme song is really good too. But what was really funny is that you'd see him like chasing. You see the pilot guy chasing some bad guy up the stairs of some office building. Next thing you know, you see the bad guy getting into some like heavily modified like news helicopter with missiles on it, right? Because all the bad guys had helicopters.
Does the bad guy have an eye patch, or is he on the good side?
He's actually the good guy. He's like the home office of the good guy. So you'd see, the bad guy take off the roof of this building in his modified news helicopter. And then, I mean, keep in mind, you just saw the Airwolf pilot chasing him up the stairs, right? Next thing you know, you see Airwolf taking off out of a volcano. How did he get to the volcano? He was in like the number 6 stairwell.
Check a helicopter.
So you see Airwolf taking off out of a volcano, and then he just went and kicked some butt. Best show. My brother and I love that show. It was the same time as like the show A-Team was on. Remember, you don't know A-Team? I swear. Mr. T. Yeah. Mr. T was deathly afraid of flying it. Every single episode they had to fly somewhere so they would somehow knock him out. And he'd wake up like in some foreign country. Every episode he'd think he'd start catching on. Because he pities the fool. Pity the fool. All right, how did Boolean Expressions get us to Airwolf and Mr. T? I don't know, but it's awesome. All right, so we have an awesome Boolean expression now, and we want to ultimately now have our math expressions, our math, what do I call it, numeric? Well, we have a Boolean operator now, so we can call our, so in Java, I'm kind of going off script here a little bit. In Java, if you think about our Boolean operators, the things that we can use to test things in our if statements, our question expressions, we have a straight Boolean expression, which sometimes you might use like the less than, the greater than, this kind of stuff. A lot of times it's numeric, right? Okay, but what if you have 2 Booleans you want to compare to each other? You need to have your logical Boolean operators too, ands and ors. All right, so, but we're going to deal with numeric Boolean operators, so numeric Booleans. And did I tell you in the assignment what to call it? I just said add it to the language in whatever way makes sense or something like that. All right, so these are the 6 things that we are adding. And these guys should all boil down to what's on the left-hand side of this, right? So we're going to have a new kind of expression. I'll put this guy after our Boolean expression. So we're going to define a,
Logic expression?
logic expression is probably good enough. Logic exp. A logic exp is going to be a lambda that's going to take in a op and a val1 and a val2. Actually, let's call it num1, num2. Because a logical math, I actually want to call it math expression, if that's okay. I really want to be explicit. So a logic math expression assumes the values we're dealing with here on either side are going to be numbers, right? So we'll name our variables with that in mind. And what's this guy going to do? He's going to create a list. We're going to call this logic math expression op num1 num2, like that. Then we'll have our predicate logic math exp, and this guy is going to be a lambda that's going to take in an LC expression as a parameter, and he's going to return whether the car of the LC expression is equal to logic math expression. That guy right there. Okay, and then we probably want to have some getters, so we'll define logic math exp get op to be a lambda that takes exp LC exp in as a parameter, and this guy will return the catter of LC expression. That's the operator. And then we'll say get LRAND for the left operand. And this will be the CADDR. And then we'll have get RAND for the right operand. Huh? RAND. That's not German, though. German doesn't have the R rolling.
No, not really.
Yeah, so we're good still. This is a mashup. All right. Logic math x get rend. Okay, so
Someone sound with that, please.
What's up?
Someone sound with
Oh, it's got to be soundboard?
Yeah. Well, it's in the recording, so.
All right.
8 minutes.
I'll write that down.
38. It's at 38 minutes.
The recording for November 11th.
I had a college prof. It was a history teacher that every time he said conquistador, he just had to roll the R, and he would it's like conquistador. And it just kept getting. Is that another one? It's 3850. So it was just, every time he said conquistador in this whole chapter we were dealing with, he would go crazy with it. Sometimes you just get the R's rolling for like 20-30 seconds just cuz. But he wasn't even doing it like to be funny. Well, at least he wasn't laughing. He was like deadpan while he was doing it.
He wasn't laughing.
Oh. All right. Okay, so get rend is going to return the DDDR of that guy. So now we have our different ways of getting our pieces, right? Okay. So, and we're calling this a logic math expression. I'm going to steal this dude here. We'll go down to our language here. And we'll put this after our bool expression?
Nope.
You don't like it there?
Oh, no.
All
Referring to something else, sorry.
right, so this guy will take in an expression. So if I'm looking at a logic math expression, so now it's kind of like a normal math expression, except we are performing Boolean logic on it rather than arithmetic, right? Okay, so we're going to go ahead and build a, actually we can do the let at this top level, can't we? So we're going to have a let, and we'll go ahead and get our individual pieces. So we'll have op being logic math expression get op expr. And then we'll have our LRAND. And we'll have our RAND. Okay. And then the body of this, we could certainly have our all our logic right in here, but I'm going to go ahead and write a helper function. So we had that for our apply math. So I'm going to now define, actually, we can actually just expand apply math with this, can't we? If we wanted to. I don't know that it's
Good. Takes it in the same amount of parameters.
yeah. Just as from a programming design perspective, is that okay? We're either doing some math, we're taking two numbers and doing something to them, and the something we're doing is based on the op. So I think that's reasonable. So we can say if op is equal, then what are we boiling down to? We're boiling it down to equal loperand roperand. If it's not equal to, then we'll boil down to not that. If it's less than, boil down to less than. Less than or equal to, boil down to less than or equal to. Greater than, boil down to greater than. Greater than or equal to. Oop. Boil down to greater than or equal to. All right, is that all the operators? 1, 2, 3, 4, 5, 6. Yep, should be 6 of them. So then we'll call apply math. I'm lost. Right here. Call apply math, passing it op, LRAND, and RAND.
Do you want to call apply expression on LRAND and RRAND?
We do. There we go. All right, so that should be our logic math expression. Okay, so now we can ask questions based on logical math expressions, right? What's the very last thing we would probably, is there anything else we would do in our language? Remember, we're kind of ramping up to doing object-oriented languages. What's the difference between a procedural and an object-oriented language?
Encapsulation.
Okay, so what I'm going to do for the homework assignment, this will be a good one. It won't be a long thing. Research procedural versus object-oriented languages. So procedural versus object-oriented. Write a 12 to 20 page. Here, I'll say 1 to 2 paging paper comparing and contrasting them. All right, so next time we're actually going to start our language over and start thinking about a language that's built on top of object-oriented concepts. All right, so for next class, try to articulate the difference between procedural and object-oriented things. Something that's maybe a little bit more involved than my telephone example that I use in the 200 class with the wires. You have the procedural telephone, and you see all the wires. You see the object-oriented looks like a telephone. So let's think about it in terms of capabilities of the language. In the next class, we'll talk about how those languages are put together. Questions, comments, concerns, bribes. And I'll put the code up so you have a final version of this code.
I have a question. Why do I need to write the Boolean expression with
I
like
thought it was still in my,
yeah? And
I know.
how's that gonna be helpful later on?
What do you mean?
It's like because like I wrote the thing, but then I put
thought
the
it was
logic
still
math.
in my